Alright, so at this point, everyone should have finished their first AI file, the Perceptron. What we're going to do now is we're going to apply the 6 different types of learners to the same data and see if there's one that kind of works out better. Because up to this point, you should have realized that a straight line might not be the best in order to classify this data. So we're going to launch, make sure they're lowercase, Jupyter Notebook. Alright, and let's get started. So, you're going to want to go into your basketball data, and everyone should look like this. You should have your Perceptron file. You should have your these three are the files you copied. Those are those libraries. And then let's look at this thing called results, okay? So we're just going to walk this through. This one prints out, how all of your learners did. So I should have showed you in lecture how to look at this in Excel, but just to look, this first number is the date you ran it, so it looks like I ran this on the 16th of June, and this is military time, so that means at 5 p.m. This is the name of the learner. This is their parameter. We're going to talk a lot about these today. And this was the value of the parameter. So the number of n-iter stood for number of iterations, and that's how many times the Perceptron was allowed to go over my data. So it looks like it was allowed to go over 10,000 times. And if you see here, it kind of has the name. So name, parameter, value, and then misses training. So right here is the number of misses you got while training. And then it says accuracy training. This is the accuracy on the training data. And then it says misses testing. That was the number of misses for our testing data. Accuracy testing. That was the accuracy on our testing data. And then final misses total and accuracy total. That was the number of misses we got in all and our total accuracy. So we can exit out of that. We're going to be looking at that a little. The first thing we're going to do is we did all the hard work by writing out this first Perceptron file. So lucky for you, you really don't need to do that again. All you need to do is we're going to click right here and hit duplicate. Okay, because all we really need to do is kind of change it up a little for the other type of learners. This is the great thing about code. You don't really have to do things over and over again. So what you always want to do is you always want to change the name. So we can get rid of this copy thing. Let's change it to the date. So whatever date, mine is like the 20. I'm doing this on the 25th. Let's say, and we're going to change the name. We're going to do instead this one called the logistic regression. Okay, so I'm going to rename that. That's one of those learners we should have covered during the lecture that uses a straight line as well. But here's the beauty. You don't really need to change much. This is where you import your libraries. You want to do the same library, so we're good there. This is where you import your data. We have the same data, so we're fine. And remember, you should have filled in these comments with what they do. If you didn't, you're going to need to go back and fill those in. Let's see. This is where we mapped all the words to numbers. So we did not 0, all start at 1. This is where we told them where our data would be. This is where we plot our data. So everything looks the same so far. This is where we standardize our data. And then this is where we split it up. So look, it went to training and testing. Good. Okay, here's the only place you really need to change it. So watch this. This cell. So we did the Perceptron, but now we want to do the logistic regression. So watch. Let's just change its name. Okay, logistic, lowercase, and then underscore regression. Okay, so it's going to use this parameter called C parameter. And we're going to start the C parameter off at 10, okay? And then all you really need to do is change this guy to be a logistic regression. And then that's really all you have to do to change it to be a different type of learner. That's the benefit of the way we set up our code. Because then what it's going to do is it's going to find the training misses, graph it, find the testing misses and accuracy, graph it, and then find the total and graph it. So if we're good to go there, let's just run it. Kernel, restart, and run all. Bum ba-dum ba-dum, bum ba-dum ba-dum. Ta-da! So look, everything on the top should look the same because we didn't really do anything different. The bottom just kind of looks a little different. So look, instead of a perceptron, we made a logistic regression. Cool. So it seems like on our training data, we had 3 misses. It looks like this. The line looks a little different if we want to go over to perceptron. Let's just look at it real quick. So this was the line it came up with the training data. This was the logistic regression. This is the line it came up with. So it looks like the 3 misses are 1, 2, 3 right there. Let's see. So did they get the same accuracy? They got the same accuracy on the training data. Let's see how they did on the testing data. So the testing, ooh, it had 4 misses on the testing data and got a 50. Not so hot. Like it looks like miss, 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 miss. Versus the perceptron on the training data only had 2 misses. Okay, so it looked like miss, miss. So the perceptron seems to look a little better than that. Here was the total. The total was 77% overall, and it looked like the perceptron overall was 83. So we can actually see those results are actually all in one place if we go to our results.basketball. Look here. Okay, so the perceptron got an overall 83. The logistic regression got a 77. So the only thing we want to do, we can kind of exit out of this, is we want to see if we can change the parameter to make it a little better. So let's try changing this 10 to 100, okay? We go to kernel, restart, and run all. Like I said, these parameters are just like tuning dials to see if we can just make it a little better. Let's see how this works out now, okay? So we go here. It looks like the line didn't really change, and the overall didn't change. Let's try one more just to see if it helps. Sometimes they do help, sometimes they don't help. So we're going to change it to 1,000. Let's see if this helps or not. And you'll see for others it does kind of really help. Okay, so oops, looks like we had more misses this time, so we got worse. So let's just change this guy back to 10. See where we go. Okay, 10 was our best. I mean, maybe let's try 5. Let's see if that works. Let's see. So we got to be 77 was the logistic regression's best one. Okay, it doesn't really change. Okay, and so as you see, exit out of the results because you need to exit out of them every time so they update. These were all the kind of ones we tried. So we tried 10, 100, 1,000, and 5. And these were all, 77 was the best we could probably get. And it actually got worse when we got to 1,000. So now we're done with that. So make sure to save them before you leave. Let's do it again. So we're going to do click here. We're going to hit duplicate. Hit duplicate. So now we're going to go is we're going to try another one. This one is called the SVM kernel, okay? So we're going to change the name as always, get rid of this copy. If it's still the 25th, we'll leave it there. And then we're going to do this thing called the SVM kernel, okay? Rename that. Alright, let's go down here. And we don't need to change any of this. Like I said, everything's the same. It's just when we do the different learner. Okay, that's why we did like all of this stuff. Is just so it told us, hey, this is the spot we need to change it. Okay, so now what we're gonna do is we're gonna change this stuff to SVM kernel. So let me get sure I get the spelling right. Okay, so we're gonna go SVM underscore kernel. And then this actually uses the same type of parameter. It's called the C parameter. And we're going to start this guy off at 10. Okay. And then we also need to change this to SVM underscore kernel. Boom. Everything else is the same. That's the only change we need to make for a different learner. Kernel, restart, and run all. go. All right. So let's check this out. So just like I said, SVMs actually can do curvy lines. So let's look. On its training data, it only missed one. That was awesome. So it only missed one. It got a 95. On the testing data, it missed 4, which is kind of bad. It got a 56. So in average, it got about an 83. That is as well as the Perceptron did. And this is the figure. But look at this curvy line. So it tried to do a curvy line. All right, so now let's see if we can fine tune it. Let's change the parameter to 100. Let's see if that will help. So we have to be an 83 overall. Let's see. Okay. Ooh, so look, we got better. So the training data, it didn't miss any. So look at this. Just like you guys were saying in class, a curvy line would probably be the best for this type of data. Okay? And so it only missed 2 on the testing now. It got a 78. So overall, it got a 93, which is pretty good. That's the best we've seen so far. Let's try changing it one more time to 1,000 and seeing if that helps. Alright, so we got to be a 93. Again, didn't miss any in the training. Missed 2 in the testing. Okay, so it looks like it's going to come out to be its 93. Which is pretty good. So watch. We exit out of this. Oh, save first. Exit out of this. Let's go check our results. Okay, like we said, so it started off in 83, but then by changing the parameter from 10 to 100 or 1,000, it bumped it up to 93, which is the best overall. Because look, we had never got higher than 83 before, now we're at a 93. So far, the SCM kernel is our best learner. And then this next one is going to kind of be interesting. Let's duplicate this. This one is what we're going to do a decision tree. So decision trees actually do rectangles and squares. But there's one kind of extra change for anything like decision tree or random forest. You don't standardize the data. So we're going to come down here and right where it says, okay, don't standardize for decision trees and random forests. All we're going to do is we're going to comment out the area that does the standardization, and instead we're just going to not do anything new to the X. So, okay, we changed that, and then all we really need to do is the same thing. We just need to change it for the type of learner. So let's go over, let's see what we got. Make sure I spell everything correct. Okay, so we're going to do kind of underscore decision free, capital T. Okay, so this is when it has a new parameter. It has a parameter called max depth. Okay, and so max depth means how many layers of questions it can ask. So we're going to make, we'll start out the max depth at 1, and we're going to go all the way down to 5 and see if it changes anything. We're going to change this SCM kernel to decision tree. And that should be everything we changed. We just changed this part. And then we also made sure that it didn't standardize the data. Okay? So, let's see how that runs. If it's bouncing around like that, you know it's working. Okay, so this is kind of cool. So with the depth of 1, it means it was only able to kind of create one question. So this is really interesting. It was only able to make one line. So like the misses train, it lists 3 on the training, and then there's 4 on the testing. So overall 77, not great. And it kind of looks like it does a straight line. So you might be asking, how is this different than like the perceptron or the logistic regression? Well, watch this. When we change our depth to like 2, let's run it again. Alright. Ooh, so what's this? This is kind of interesting. Now, it misses only 2 for the training because look, with more depth, it's able to do kind of cooler shapes. So it's able to do this and get a little better. but it still had 4 misses on the testing, which means overall it got an 80. So it's getting better. Awesome. Let's see how high we can get it. Let's change our depth to 3 now. Let's see how this goes. Alright. Depth to 3. Still had 2 misses on the training. 4 misses. It looks like it's about the same. Okay, so overall got an 80. And let's try changing the depth to 4. This should give us a little more of an interesting shape, I think. Because the more depth we add, the more it can kind of do with its cooler shapes. Okay, so now, look at this. Now we have kind of a zigzag box. And look, now it only missed 1 on its training data, and it only missed 3 on its testing, so overall 87, that's what the overall one looks like. Not bad, okay? Actually pretty good, 87. And just for kicks and giggles, we'll turn this to 5 and see if that helps at all. Ooh, it actually made a different shape. So here, for the training data, it didn't miss any. And for the testing data, it missed 3. So overall, 90. Nice. Okay, we're going to stop there. If you wanted to try some other ones, you can. Let's move on to the next one. Make sure to save it. Okay, so now we're going to kind of keep in the same family. We're going to copy the, where is it? Oh, we forgot to rename it. Let's go here, sorry. Always rename it. So we're going to go here and we're going to change this to the decision tree. Decision tree. There we go. Boom. Now we can save, exit. Alright, so now let's make a copy of the decision tree. And we're going to do its kind of, brother, the random forest. And so let's change our names like we forgot to last time. We're going to name this random forest. Okay, so we're going to go there. And then let's scroll down. The thing we need to make sure with the random forest and the decision tree is we do not standardize the data. So I have it correct here. I don't standardize the data. I commented that out, and then I just don't do anything to it. Okay? So then we go down here. Everything's the same. The only thing we need to change is right here. So what we're going to put is we're going to put random, lowercase, random forest. And this one has a parameter called number of estimators. So hopefully by now I've covered in class what a random forest is. It's just a lot of decision trees together. And so watch this. We're going to start at 2. We'll start at 2. And that's the number of decision trees it's going to have working on this. And they're going to vote at the end, and the majority wins on what classification it's going to give the data point. So we also need to change here to random forest. And everything's set. Let's go kernel, restart and run all. Try this out. Alright, so like I said earlier, this is kind of like the decision tree, so it gets to do boxes. So look, training data, it missed 3. Testing data, it missed a lot, 5. So this one looks like it kind of is not so hot right now. It missed a lot on total. It missed 8, so like 1, 2, 3, 4, 5. Oh, 6, 7. And maybe I'm missing one. Yeah, I missed a lot. So now let's try changing the depth of our decision tree. Let's try going to 4. So I'm going to restart and run all. So we got, I think 93 is our highest so far. So let's see if we can beat that. Boom, so this one's a little even more interesting. Okay. Training, oh, now it only missed 1. And look, it kind of made different box shapes. Testing, it still missed 5, so overall it's an 80. Not terrible, it's getting better, but let's try bumping it up. Usually, the more trees you have, the better. It just takes longer to compute. Let's see that. Let's try. So we're trying 6 now. We got to be an 80 was the best one for this guy. And as you notice, it took a little longer to do. Overall, now we got an 83. So look, this is like even more. The more trees it have, the more complex shape it could create. And then, so that was 6. So let's try bumping up to 10. Let's see if that does anything. I think we may be getting on our limit of how well it can do. Let's see. And as you notice, it's taking longer and longer each time we add more trees. Okay. So, training, perfect. Testing, we missed 3. Overall, 90. Nice. Last one, let's see if 12 trees will work. There you go. And so there's a point. It's like, sometimes when you study, it's like no matter if you study a little more, you're probably going to get the same grade if you studied a lot at this point. So as we add more and more trees, we might, if we kept adding some, this might not improve anymore. We might have reached our limit. And so yeah, the total is 90 again. We have this new shape. It looks like that. And that's kind of our total. So we're still at 90. I think this is as good as we're going to get. Okay, we're going to save. So now we're going to try this thing called, duplicate that. We're going to go and let's do the SCM linear, okay? So this is exactly kind of how it sounds. This is another one of those that can only draw a straight line. But it draws it and it kind of calculates it in a different way than the perceptron. So as always, let's change our name. We're going to go to SCM linear. Okay, nothing needs to be changed. We're still using the same data, still using the same library, still converting the same words to numbers. We do need to make sure that this time we do standardize the data, because we only didn't standardize the data for the decision trees and the random forest. So now we need to kind of change it back. Okay. And then, okay, so let's change this to the SCM linear. Let's see, SCM, and then lowercase l linear. This has the same thing as the SCM kernel. It has a parameter c. We're going to change it to 5 first, okay? All we need is to go out here and SCM linear and make sure there's parentheses. They always need to be matching. Alright, let's try this now. I think I got everything right. Kernel, restart and run all. Boom. So like I said, it's going to be a straight line. So look, training, it got 2 wrong, so I got a 90. Testing, it got 3 wrong, so I got a 67. So overall, it got an 83. Kind of looks like the perceptron, okay? Let's see if we can tune it with the parameter to make it a little better. Let's change this 5 to 10. And you may be saying, like, what if I'm not remembering how it's doing? Don't worry, I'll show you after this. It runs this time. We're going to go back to our results, and it's keeping track of everything we've run. Let's see. Again, it missed 2 on its training, missed 3 on its testing, and then overall had an 83. So if you're curious, watch. You can always just go back to your results, and let's see everything we've run. This is the big list of all we run. So look, now we're on the SCM linear. We ran the random forest that many times. And then, let's see. Yep. So those are the 2 we ran. Let's try it one more time. Let's try bumping up C to 100. And let's see if that gives us a little better. So the one to beat was, our last one was an 83. So the next out of that. So our total is still an 83. Okay, maybe we're not going to get any better. Okay, so let's save. The last one we're going to do is we're going to do this one called K nearest neighbor. Okay, so K nearest neighbor is where it just looks at the closest data points, and it kind of votes. It selects the one with the most neighbors. So if most of the neighbors are the X's, it's going to make the new data point an X. If the most of the neighbors are the boxes, it's going to make the new data point a box. So we're going to call this K nearest neighbor. This is KNN. We scroll down. We need to make sure that the data is standardized. Okay, so let's make sure. Yep, we are standardizing the data. The only ones we don't are the distance between the random forest. So let's change this one now to KNN. Let's change this to KNN. And then we need to change the parameter name to this thing called n neighbors, okay? And then we're going to change the first neighbor to 1, okay? And then the only thing else we need to do is you need to type KNN here. And look again, we're using my tool, my kind of library, but there's a lot more code that goes into it, but I'm making it easy on y'all. You could just use my library. And so now, let's run it. So this means it's just going to look at the closest guy, and whatever the closest guy is, it's going to make the new data, it's going to predict the data point's going to be the same as the closest guy. So let's look. Ooh, interesting. It looks like this. So the number of misses are 0. But the number of testing misses are 3. So probably missed that one, and that one. So total 90. Not bad. Let's try bump it up. You kind of want to usually make them odd numbers. Let's do 3. Alright, another weird shape. Let's see how it is. Training, it missed 3 this time. See, testing, it missed 2. So overall, it missed 5. So it actually got worse. Let's try 1 more. Let's try 5. Alright, let's see this. So it's going to kind of use the 5 closest neighbors and have them vote on what it's going to be. So training missed 3 again. Testing only missed 1. Overall 87. Nice. And the last one, let's just change this to a 7. See what we got. Okay, so let's see. Training, again worse. We missed 4. Testing, we missed 3. Overall missed 7, 7, 7. Okay, so we probably hit our best. So if we go here, let's save it. Let's look at our results and let's kind of try to interpret them. So the results, let's go try to find which learner was the best. The best learner was, okay, so 83. I think it was this 93 thing. So the SCM kernel, the one that made a curvy line. And so the closest one is a 90, and a couple of them got it. Like this random forest got a 90, decision tree got a 90, and K nearest neighbor. So sometimes you can't have them tie for how, just like you're doing track or soccer. But it looks like the best one is SCM kernel. And this is kind of cool. This is what you guys had predicted early on, was that, hey, a curvy line would probably be best to separate this data. It looks like, you guys are right. It looks like this curvy line was the best we could get. It just goes like that. Boom. So that's how you kind of run it for all different types of learners. You find the best learner. And this is pretty accurate. This is 93% accurate. So you can take this prediction and then determine if an NBA player next year falls in this red spot, probably not going to be an all-star. If they fall in this blue spot, probably going to be an all-star. And there you go.